non-turbulent flow. We don't get the porosity, so we can heat treat and use some different alloys to get very good mechanical properties. Of course, just like semi-solid materials, we have to cast thick walls. We need larger gates, so we can't trim them off, so we have a secondary operation for cutting them off. And we are, again, limited in our die geometries, or the geometries we can cast, and the number of cavities we can cast, because we have to get that directional solidification. Now, the last high integrity process is actually high vacuum die casting, and this is where we drop the cavity pressure below 100 millibars or less. In fact, I've been talking to some guys who are really pushing the envelope here, and guys are actually getting below 50 millibars now in the die casting die. And what we achieve by doing that is we pull out all the air before we fill the mold, and by doing that, we greatly reduce the amount of porosity that we're going to see in that casting. This is fantastic for making heat-treatable die castings, especially very thin-wall heat-treatable die castings. And I'll show you some examples of that coming up. But really, the place where this technology has taken off is in crash-resistant automotive castings. And so, although we won't show the pictures in this slide today, as a little bit of a homework assignment, you can Google the Audi A8 die castings, and you'll see that that car is actually made of 28 separate thin-wall, high-vacuum die castings to make up the frame of that car, and it's quite impressive to see. And so I want to spend now the rest of the next 5 or 10 minutes or so talking about some applications, and the goal here is to just give you an idea of the breadth of what we can do in die casting. This is by no means an exhaustive list of what you can do, and I'd strongly encourage you to go to diecasting.org/casting/database, where you can see hundreds of castings of what have been made over the years, and what people have generally seen are some of the best castings in the industry. And when you go there, what you're going to see is just a list, and you can click on these castings and see pictures. You get an idea of the relative size, the end markets, and you can really follow up and get a great idea of what's possible. I like to use the turbocharger impeller as a great example. I regularly get calls from people saying, you know, could I cast something like a turbocharger impeller? And when you have that kind of a question, if you go to this website, you can actually scroll through all these examples, and quite often you're going to see that that example has already been made before. So here's a quick example of just giving you an idea of what you're going to see on that site. Here is something that many people here might have seen before if you've ever been shopping for clothes or something like that at a department store. You're going to see these little tags that keep you from stealing the clothes, and there's a little zinc die casting they use to hold these on, and this was a big deal for the supplier, this particular anti-theft device, because it didn't require me to put a hole in the product. And so you can see that this is just a nice little, it's a 0.35 ounce zinc die casting. It's done on a miniature zinc machine. And they're making 100,000 parts every 4 weeks, or 25,000 parts a week, which is just a phenomenal production rate. This is another casting that I just find infinitely impressive. This is actually a casting that's made by one of our sponsor companies, Twin City Die Castings. And what you see here is this is a 380 aluminum die casting. It's a little under 2.5 pounds, and it's actually roughly 12 inches by 12 inches. This is a rack-mounted electronics housing. And look at all that detail that you see in there, all those fine little holes and those thin fins built into that. You can imagine machining this component was extremely expensive. And so they were able to build a die in about 8 weeks and go into production on this part, which is actually a relatively low volume casting, but they were still able to see significant cost savings just because you can see all that complexity and intricacy of that part, but by being able to die cast it, I can actually make it much better than if I tried to machine it out of a block of aluminum. Now we're going to get into some more detailed parts and just show you some again, applications of the results that people are achieving. So there's steering knuckles that are actually squeeze cast on the Jaguar XK, I believe is the car it is. And here you can see that they do a lot of testing. But the thing that I found most fascinating about this part is when they went to a squeeze cast aluminum part, versus a forged aluminum part, I believe, or a sand cast aluminum part. It was one of those two. They actually started breaking their test fixture. So instead of being able to